Example 1.16 says, a 2.5 kilogram brass ball at 100 degrees Celsius is placed in an insulated container of water at 10 degrees Celsius. When the ball and water reach thermal equilibrium, their temperature is 30 degrees Celsius. What amount of heat is transferred between the ball and the water? So to figure that out, we're going to use the equation that we used for example 1.15 that says heat is equal to the mass of the object times its specific heat times the change in temperature of the object. So the mass of the brass ball is given as 2.5 kilograms. We can look the specific heat up in table 1.7 and find that the specific heat for brass is 0.091 calories per gram degrees Celsius. However, because the mass is given in kilograms, we need the specific heat to be in kilograms as well. And in fact, if we change grams to kilograms and calories to kilocalories, we would end up multiplying both the top and the bottom by 1,000. They would actually cancel out, and we get the same numerical value, just with the revised units that we need. Lastly, to find the change in temperature, we need to take the final temperature of the brass ball and subtract the initial temperature. So the final temperature of this ball is 30 degrees Celsius. Its initial temperature was 100 degrees Celsius. When we subtract, we will get a temperature change of negative 70 degrees Celsius. Finally, we can substitute these values into our equation. Mass is equal to 2.5 kilograms. The specific heat is 0.091 kilocalories per kilogram degrees Celsius. And lastly, our temperature change is negative 70 degrees Celsius. The degrees Celsiuses will cancel out. The kilograms will cancel out, leaving our answer to be in kilocalories. And it's going to be 2.5 times 0.091 times negative 70. Multiplying these values out, we get that this is equal to negative 15.9 kilocalories of heat. Or, if you prefer, negative 15,900 calories. Now, this value is negative because this is the amount of heat that the brass ball lost as its temperature dropped. Part B of this problem asks us, what is the mass of the water in the container? So in order to figure this out, we're going to use the same equation. Q is equal to mass times the specific heat times the change in temperature. However, we want to solve this for mass, so we divide both sides by the specific heat and the change in temperature. When I do that, of course, on the right-hand side, those values cancel out, and I'm left with mass. And mass is equal to the heat that is used divided by the specific heat times the change in temperature. So for the heat that the water has absorbed, it's equal to the heat that the brass ball lost. And we figured that out in the previous problem. It's 15,900 calories. So the brass lost it, which is why it's negative. The water is gaining it, So it is a positive 15,900 calories. We know that the specific heat of water at this point is 1 calorie per gram degrees Celsius. Lastly, we need the temperature change of the water. The water started at 10 degrees Celsius and went up to 30 degrees Celsius. So the final temperature is 30 degrees Celsius minus the initial temperature of 10 degrees Celsius, meaning that the water gained 20 degrees Celsius. Substituting these values in, 15,900 calories divided by the specific heat of 1 calorie per gram degrees Celsius times 20 degrees Celsius. The degrees Celsius cancel out, the calories cancel out, and the grams are going to move up to the numerator, giving our answer in grams. And it's going to be 15,900 divided by 1 times 20. If you divide 15,900 by 20, you will get 795, and our answer is going to be in grams.